Okay, let's start. Good afternoon, everyone, and thank you for joining me today. I am Ashish. I'm a solutions engineer at DevRev, and today I am here to talk about one of the critical issues that is arising because of AI, because one of the recent risks, because GenAI is getting deep and deep involved in our daily workflows, and we are giving it a lot of permissions, extensive permission, and access to our resources without realizing about the security implications at most of the times. And today, I'm basically going to talk about how we got where we are in the AI landscape, what are the risks that are associated, and finally, what is the solution to the AI problem. So the title is Your AI Agents Are Overprivileged. It sounds a bit dramatic, but during the course of the talk, you will see what this title is all about. Before we begin, just a little bit about myself. I have a career which has been around AI and security, and it's an interesting one. I started off as a freelancer for 7 years, where I was mainly building conversational AI apps for Amazon Alexa, Google Assistant, Bixby, and Rasa, Dialogflow, if anyone remembers these terms from like 6, 7 years back. I was heavy into that space, and I used to host a lot of events, meetups, create courses for building these voice bots, and for that, Amazon recognized me as an Alexa champion. One of my apps also ended up winning the Webby Award, and then I decided to take a pivot and join the security side of things, where I joined Okta, which is a cybersecurity company, a couple of years back. There, I was primarily focused on the customer identity side of business, and I got to work on the Auth0 product a lot. That's where I learned about authorization, identity access management, SSO, all the keywords related to security. But last month, my passion for conversational AI, where I spent 6 years earlier, brought me back to a startup called as DevRev, where we are building a knowledge graph for your business to eliminate the silos. And now I'm back in conversational AI. When I'm not working, I just love playing chess, watching sci-fi movies, learning languages, and traveling a bit. And the last point, if that piques your interest, you can always catch me after the talk to learn about how once my app saved a little girl from a troop of monkeys. I know that sounds wild, but it's a true story. Okay, let's take a look at what we are going to cover today. This is our short agenda. We will start by looking at what is the AI's, how AI has been growing exponentially over the last few years. And then we will look at how access control has evolved over the years from the very traditional approaches to the more modern ones that we are implementing in our solution. Next, I will introduce OpenFGA to you, which is an open source project which is used to implement fine-grained authorization. I also have a couple of demo apps that I have built that I will show you. And finally, I will share some tools and resources that will help you along your FGA journey. So let's begin by setting the stage and looking at the incredible pace of AI's growth. So the way we interact with technology has evolved quite a bit over the last few decades. Every 10 years or so, there is a paradigm shift. In the early 2000s, it was the web era, where people were signing up to websites with just their email and passwords. SAML and SSO were quite a norm, and the authentication in those days was pretty limited to that. Then came the mobile era, where everyone started having a smartphone, and there were new ways of implementing security, like there was biometric authentication, multi-factors, and we also started developing some standards around those times, like OAuth, OpenID Connect. So we started doing that, and in the 2020s, we moved to what I call the agentic era, where AI agents is the new way we interface with any digital technology. But the problem is that the authentication that we used for the web and mobile era doesn't quite fit in the agentic space. It has to evolve to meet the specific requirements of the AI agent side. And with that, we'll look at what do we mean by the agents era. Now, it's not that AI has been just coming up in like last 2, 3 years. It has been here for a while now. Like in early 2000s, we had the neural language models. Then we had like transformer-based models. Then we had consumer-facing conversational AI apps. This is where I started my career when I was building those bots for Alexa, Google Assistant in early 2017, 18, and it was quite the rage. Like everyone wanted to be on these voice apps. Now, not so much, but yeah, we then moved to the LLM space, the GenAI space, and that's where we see the explosion in this market. It has reached the inflection point because over the last 2, 3 years, we have seen it has become so easy for everyone to converse with GPTs, create images, all those things. And that's only because the large language models have evolved so much in the last 2, 3 years. So how are these AI agents actually changing the way we work? We can essentially break it down into 4 main things. The first is GenAI. It is the engine that creates new content like text, images, or code, or anything. It can be anything, like a draft email summary, or create an image, write a code to do something. Did anyone here try out those Ghibli image trend when it came out? Anyone made a Ghibli image? Oh yeah, we have one. I also did. So yeah, no shame. So that's the like GenAI. It will create something from scratch. It's not using existing information. It can build something that has never been seen before. So that's the GenAI side of things, and it is becoming more and more capable by day and integrating into our lives even further. Now, the next way is like how do you interact with these GenAI agents? You don't necessarily have to write code to talk to these agents. You can just talk to them using plain English or whichever language you speak. Like, it can be done in a natural language way. You don't have to write commands to work that. That is what we call prompting. And this is where you just say, hey, can you generate a summary of this sales call and provide it a video, and it will do that. So prompting has made it easy for us to work with these AI agents. The next part, and the real game changer, is AI agents with tool calling. This basically means that the chatbots from the past days, which used to just take a question and give the answer, they are no longer just basic chatbots. They are actual helpful assistants that not only answer questions, but also perform actions on the user's behalf. These actions can be calling some APIs, calling additional tools, making a reservation for you, or performing some set of tasks, creating some components in code. It can be any action. So they are not just answering questions, but actually doing things. And that makes them quite powerful. And lastly, RAG. So as we all know that most of these large language models, they are trained up to a certain date. And post that, if you ask some question, or if you ask a question that is very relevant to your business context that the LLM wouldn't have any information about, most likely they will give you a made-up answer. They will be hallucinating and give you something, some random response. That's where RAGs are useful, because RAG stands for Retrieval Augmented Generation, and RAG essentially means that you provide additional data, relevant data, to that LLM model so that it can answer questions that are related to your context. And RAG makes some really powerful use cases, and the combination of these capabilities creates a powerful paradigm for the AI and in the agentic era. So to sum up, there are 2 new sides of AI. The first one is where it can interact with people. It can interact in a natural language way. It can handle any unstructured input. Like, we can just dump almost anything, and it will try to make sense out of it. And it can derive and utilize the contextual information and give you a relevant response back in your language. And the second part of this AI is where it performs tasks. So this is the agentic side of things, where it can call APIs, it can use the different tools to perform tasks, and it can also recover from errors by itself without supervision. Like, if anyone of you tried vibe coding with Cursor or Windsurf, you will see that sometimes it fails to do something, but then by itself it will figure out, hey, this might be the error, let me try something else, and then it builds that specific part. So it can recover from it, and most of the times it doesn't require human supervision. And that is a good thing, but that is also where, if it doesn't require supervision, if it gets too many permissions, that's a recipe for disaster as well. And that is what makes them prone to significant security risks. So keeping all this in mind, it brings us to the critical question that, hey, AI is wonderful, but what about the security implication? And that is what most people in industry are asking. Like, if I show you some examples, as you can see from these quotes from some industry leaders, that they are asking about, or they are growing concern about the security implications of AI agents, and they are asking how are we going to solve the security and auth concerns for these powerful new AI tools. They are also organizations who are worried about adding Copilot into their workflow because they usually bypass critical security measures and access private data, confidential data. And this is not something which is just happening in a few instances. We have seen multiple instances of such breaches or such data leaks happen. And the consensus is clear. While everyone is trying to build an internal tool which leverages AI to speed up workflows, we still haven't figured out how to secure them properly yet. And the consequences of not addressing these problems is huge. And we have seen some incidences. I will show you some examples that you might have also seen on the internet. Like once there was this person, Chris, who almost bought a Chevrolet Tahoe for $1, and the car costed like $60,000. He just tricked the chatbot into offering him a really great deal. Then there was a Air Canada chatbot, which offered a massive discount to a user. But then later, Air Canada was declining the discount, and then the user took them to the court, and they finally had to pay it. And then Samsung banned their staff from using ChatGPT in 2023 because someone put sensitive confidential data in GPT to answer questions, and that led to data breaches. And very recently, I saw on Twitter that someone was vibe coding like most of us and using Replit to build something, and everything was working great until Replit did something and dropped their entire production database. Anything like that ever happened to any of you? Thankfully, it stays the same. It hasn't broken anything for me yet as well. But yeah, we have to be careful. We have to have guardrails, because if something like that can happen to a person, it can happen to any one of us. Like your production DB just gone, and you didn't even know about it unless you check yourself. So these are just these examples are just like the tip of the iceberg. There is a OWASP community which has prepared a list of all the security risks associated with large language models. And we can see these include issues like prompt injection, where an attacker can manipulate the AI's instructions, like the way that person who ordered that car for $1 did it. And then there is sensitive information disclosure, where sometimes AI will reveal confidential data to unassuming public, and that it shouldn't do. And then there is excessive agency, where we give an AI tool too much power to do things, like in the case of the Replit user, where the AI had too much power to delete the production database by themselves, and it ended up being a disaster for them. So out of these issues, some of them are core ML, LLM issues that are sometimes outside the scope of GenAI application developers, but most of these are often within our control. The ones in red are often within our control, and we can handle them. Excuse me. So when you decide to build a AI app, there are mainly 4 security or auth concerns that you must address. These are the 4 concerns, and if you do take care of these properly, then you significantly reduce the risks that we just discussed in the LLM list. So let's take a look at each one of them a bit more in detail, starting with the first one. The first requirement is AI needs to know who I am. This is all about authentication and setting the user context. This is the process of verifying whether the user credentials are correct. We can validate them using email password, biometrics, single sign-on, whatever. Doesn't matter at this point. But once we have validated the user, it's not just about proving the user is who they say they are. It's also about establishing the context in which they are accessing the application. What is their role? What permissions have they got? And then once we know everything, then we set up the foundation upon which the AI agent will keep on performing the other tasks. So once we know who the user is, the next step is to control what the AI agent can do on their behalf. So for AI agents to be truly useful, we saw that tool calling is a major thing. And this is a main requirement when you build a GenAI app. So for them to be useful, they need to interact with tools and APIs. And for that to happen, we need to ensure that the AI agent has a proper context. It only performs those actions calls only those APIs which that specific user is authorized to access. And this is typically handled through tokens like OAuth 2.0 access tokens, where you specify which scopes the user has access to. And it's crucial that these tokens are properly scoped, because if you don't grant only the minimum permissions, then the AI can almost do anything with those APIs. It can delete databases rather than just update or create. So scoping them correctly is very important. But what about some task which takes like longer time to complete? This brings us to the next challenge that comes with building an AI application. AI uses async interactions. So there are sometimes tasks that take like not just seconds, but like minutes or hours. And during this time, the AI will be acting on your behalf. It will be like when you try to code something with cursor, sometimes it takes like 5 or 10 minutes to complete that part, because it is performing multiple steps. It's installing like the node modules, then it is setting up something else, creating databases, and it has a few steps to go through. So rather than waiting for your approval at every part, it assumes the responsibility of based on your previously given consent, and it does that. So async interactions are another thing. And finally, we have come to the most critical requirement for securing your GenAI application, which is AI data access must consider user permissions. And this is the fourth and final requirement, and this is the meat of our talk today. And when we are building any agent with RAG, we are giving it a lot of data to generate its responses. And that data is usually a company's confidential internal knowledge base, their CRM, their customer data. And we want to make sure that whenever a customer comes to their chatbot or their website and asks a question, their chatbot only replies back to them based on the context that it is provided, and it doesn't give out any information which is confidential and not useful, not intended for that specific person. And this brings us back to the OWASP top 10 list. Sensitive information disclosure is the second biggest problem in the GenAI security landscape, and this is what we are trying to address today. Okay, so let's understand this by an example. So you are trying to build a AI knowledge chatbot for your application, and these are some of the rules that your chatbot will be based on. The AI agent can only access a company's public record. For anyone who is coming directly on your website, they will not see any internal records. They will only see the public documentation. And if they're authorized, then they can probably see some other documents. The AI agent must also not modify any existing records. And then finally, the agent must not access records belonging to some other employee. If one employee logs in, if let's say someone in the finance department logs in, then he should not be able to see the records for someone who is in the engineering department. And with this example in mind, we have to think about how can we enforce all of this at runtime. The answer to that is using authorization. Authorization is the missing link, and we will be using authorization to solve all of these rules. So just a quick step back before we dive into authorization for AI agents. Just a quick primer on the importance of authorization and how does it differ from authentication. So authentication and authorization are quite similar, quite important in the security landscape, but it's easy to get them confused. Essentially, authentication is who are you, and authorization is can you do that. Authentication confirms like users are who they say they are. Authorization gives them permissions to do certain things. Like when you walked up to the reception and you grabbed your badge by showing your QR ticket, you are just validating yourself that you are who you say they are. But then you were authenticated, and then you were given authorization to attend talks in like all these 6 rooms. Whereas me, I am a speaker. I got the privilege to also get a chance to enter the speaker room. They gave me an additional code to access that room. So my authorization is a bit different from a regular attendee here. So this is how authorization and authentication differ. And yeah, as I mentioned that I love traveling, so I always try to draw analogy to authentication and authorization in my trips. And this is me recently. On the left-hand side, I was in Ireland, in Aran Islands in Galway. And on the right, I was in a cave in Budapest in Hungary. At both these places, I had to buy a ticket to go on the tour, and when I reached the meeting point, I had to show my ticket. I had to validate that I am the guy who bought the ticket. I was being authenticated at both these places. But my authorization at both these places greatly differed, because on the left image, I'm pretty much sitting at the edge of a cliff, and there was no one to regulate me, whatever I was free to do, almost anything. And but on the right-hand side, where I was in a very controlled environment, I was under the strict supervision of a guide. My authorization was very much limited to doing whatever that guide was telling me to do. And in cases like this, if I had better authorization in a cave, then the consequences of things going wrong were much higher. So it's the same like when you build an application. Things can go severely wrong if someone with bad intentions or someone just not knowing what to do gets access to the most critical sections of your application. If the authorization is broken, then yeah, they can end up harming themselves or your application, anything like that. All right. And that brings me to another fun fact. Broken access control is the #1 most common web application security risk. So our friends from OWASP, who I shared about earlier, they also did a research on the top 10 application security risks. Here, we are just talking about traditional web application, not the AI application. And access control was the #1 problem there as well. But what makes authorization or access control so difficult to get right? It's actually the amount of variables that are involved. Authorization is complex because there are so many elements to it. So let's understand this by an example. Let's say you are trying to have some sort of authorization logic in your company. You have, let's say, 500 people in your company, 500 number of users. Now, all the rules for these users differ quite a bit. There can be employees, there can be contractors, there can be interns, there can be partners. So different roles for every user. Now, these users can also be distributed into different groups. There can be an engineering group, there can be a marketing group, there can be a product group, sales group. So different number of groups. And all these groups can have different types of resources associated to them. Resources can be applications, like the engineering group will have GitHub access with them, the sales group will have Salesforce access with them, marketing group might have HubSpot. So again, they have different resources. And even within those resources, they might have different permissions. Like the front-end engineering team might have different access to GitHub repo of just the front-end part of your application, and the ML team might have access to different repos. So these permissions also differ, even within those resources. And finally, all these instances keep on changing constantly. Let's say a new employee joins your company. Now you need to provision access for him for all these 50 different applications. And let's say someone decides to leave the company. How do you ensure that you have removed each and every access for him? So this is what makes solving authorization quite complex. And this is why it is a major challenge for any organization, because there are too many variables, and if you miss one thing, you just leave a pretty big surface area for any breaches. And that is why so many applications usually end up with broken access control. Let's take a look at how we have tried to solve this problem over the past decade. And we will start with some very simple methods and then move on to more modern approaches. Now, before I go into this, just a bit of a disclaimer. There is not a right way or a wrong way to do access control. There are different ways to solve different problems in access control. All the methods have their strengths and weaknesses, but we just have to find the right fit for our specific application. OK, so it all started back in the 80s, where they tried to do access control with just access control lists. They just had defined read, write, execute, and it was answering simple questions like, does Kate have read access to this file? True, false. If it's true, Kate has access to that file. And nothing more than that. Very simple, very basic, and that's it. Later, they moved on to something called as role-based access control, which is also known as RBAC. And it is the most common way people implement authorization in the traditional web and mobile applications. And RBAC generally checks authorization decisions based on roles. It could be like, roles can be any group or type of people, like it could be, like in this example, it's a product manager role. So let's say there is a product manager role, there is an engineering role, there is a finance role, and in our application, we will just check, is Kate belonging in the product manager role? If yes, we will give her access to this document. If not, we won't. RBAC works great. Lots of applications use that, but there are some drawbacks to it. Since RBAC is checking on just roles, it is a bit rigid. Let's say you already have like 10 or 15 roles defined for your company. Now you need to add one more person, one more type of role. Now you need to go and check everywhere in your application code layer where you have those RBAC related checks, because essentially it's just if-else statements checking whether if Kate is dot role equal product manager, allow her access. So you have to go and check all those statements and add that new role that you wanted to add everywhere. Let's say you wanted to remove a role from your list of 15, 20 roles, then again you have to go to all those check statements and remove it out. Now this does leave this might lead to inconsistencies in case you miss removing it somewhere, and then it's again a recipe for disaster. So that's a shortcoming of RBAC. And access control risks and RBAC are example of coarse-grained authorization, where you are just leveraging a single attribute to perform these authorization decisions. What's better than coarse-grained? Fine-grained authorization, where you start to leverage more than one attribute or a combination of different attributes to make the authorization decision. One example of at leveraging multiple attributes for authorization is attribute-based access control, where we check a person's authorization access based on some attributes. Now, these attributes can be anything. It can be like time of the day, person's designation, their role, their IP address, anything that can be associated with that person or that resource. Like in this example, we have, is Kate in the product department, where we are checking the attribute department, and is it working hours for Kate? So we are also checking the attribute time, and based on that, we are combining these attributes, and finally, we are reaching the decision whether to allow Kate access to this document or not. Where ABAC falls short is, let's take an example where we are trying to determine access for a document which is inside a folder. Then that folder is within another folder, and that folder has another folder. So 3 layers of folder, and within that there is a document. So when we are checking the access, we'll first check for the top level folder, then we will check in the second folder, finally the third folder, and then we will finally check the access for that specific document. Imagine if that access is not there for that document. Then we wasted like 3 database queries over those folder checks, because we couldn't directly check for the document. We had to check recursively from top down. And at this time, we are always calling our production database, because all these traditional access control methods reside within your application layer. They are not decoupled from your application logic. So this is one shortcoming of ABAC. So what's better than ABAC? It's relationship-based access control. This is where we move from rigid controls to a more flexible relationship-based approach. Here, we don't need to define like roles or permissions. We can just specify one-to-one relationships between different elements. Like the first one can be Kate belongs to product department. And then we can define a separate relationship that product department has access to product folder. So that's the second relationship. Third relationship can be product folder has access to the roadmap document. And so we have 3 independent relationships. Then we can ask the question, does Kate have access to the roadmap document? Well, directly, she was never assigned the roadmap document access. But we can, from our 3 relationships, we can generate a graph. And through the hierarchy, we can see that since Kate belongs to the product department, and product department has access to the product folder, and product folder has access to the roadmap document, Kate should also have access to that roadmap document. And this makes it quite flexible, and we are able to leverage multiple attributes all at the same time. And we can dynamically change permission, add new relationships every time. So RBAC overcomes all the shortcomings of traditional access control methods. And coming back to our GenAI discussion, which authorization system works best for AI apps? It's RBAC, because RBAC is based on relationships and provides us much more finer access control capabilities, and which is necessary for like securing the AI apps. Now, let's see how we can implement the fine-grained reback control in our applications. We will talk about an open source project called OpenFGA, which is one of the ways you can implement fine-grained authorization in your application. OpenFGA is an open source solution which is owned by Cloud Native Computing Foundation, and it is maintained by my ex-company Okta. And it also has a contributors from a lot of different companies, and it's a quite actively maintained project. And it is used as the core of Auth0 FGA, which is a managed offering from Okta. And the only difference is that Auth0 FGA has a DynamoDB backend, so if you have like scalability needs and all, then you can consider that. But if you want to host everything on your own server, then OpenFGA can be used with Postgres, MySQL, SQLite, and can be deployed on your own servers. OpenFGA was inspired by Google's Zanzibar paper, which describes the highly scalable and globally distributed authorization system that Google uses for all its services. When I talk about Google services, think of Google Drive, Google Docs, YouTube, Google Photos, everything. So you can imagine the insane scale at which FGA in general can work. All right, so where does FGA lie in the whole authentication pipeline? FGA is independent of the authentication service. So how does a traditional way of doing authorization look like? So when you have an application which is doing authorization like the traditional way, there is a user who is logging in using some identity provider. It can be Auth0, it can be Clerk, it can be WorkOS, any open source provider, it doesn't matter at this point. And once they validate their credentials, an access token is generated. That access token can be then used to validate and call another API, another resource. And this is where we have our traditional RBAC, ABAC, everything going on. Everything is in the application layer. But when you implement OpenFGA or FGA in general, then the first part remains the same. Just before the validation and before calling the resource API, you make an additional API call to the OpenFGA service, where you are just checking. You're sending it a user ID and then sending the relation and the resource name. And by calling this check API, you get a Boolean response, whether the user has access to access the resource API or not. If it returns true, then you can proceed and call that API. If it returns false, you can just throw a 403 forbidden error at that time. Okay, this provides some secondary benefits as well, like you now have a centralized authorization. Authorization is decoupled from your application layer, and you can manage it seamlessly for all your products. Let's say you have a web app, you have a mobile app, you have a secondary application for some other service. Now you can manage authorization for all of them at a single place, rather than duplicating the effort at everyone. And this makes the authorization rules quite explicit across the entire company and all the products. And this also helps with maintaining compliance and audit purposes, because you get like proper logging and details where every decision was taken on. And lastly, it helps to easily implement authorization for any new feature or new product that you are introducing, because you already have the relationships separated out. You can just start adding new tuples to it. So let's see how FGA works in a more technical sense. There are 3 core elements to an FGA relationship-based access control method. The first one is the authorization model. The second one is relationship tuples. The third one is the access control checks. Let's dive deeper into the authorization model first. So think of it as the database schema, where you define the different type of elements in your database. And let's say in our example, we have a user, a document, and a folder. And the document has multiple relationships. Like it has a parent relationship, like any document can have a folder as a parent. Then it can have a owner, like every document will have an owner, which is of the type user. And finally, we have another relationship, which is of viewer. So the first one is the user, like any document can have a viewer directly assigned to it. And then we have an owner who can be assigned as a viewer. Like anyone who owns the document obviously will have viewing rights to that document. And the last one is interesting, which says viewer from parent. If you check the next relation, which is type folder has a relationship type of viewer. So we can assign a user as a viewer of a folder. And in the previous one, we see that viewer from parent. So who is the parent of a document? Documents parent is a folder, and viewer from parent is the user who was assigned as a viewer to the folder. So we can build a relationship that whoever is a viewer of the folder, by default, they also get viewer access to any document which is inside that folder. This is how we can define a schema for our relationship-based model. And once we have defined the schema, the next step is to fill in the data, which we do in the relationship tuples part. Here, we can specify three things: the user, the relation, and the object. So let's say, for example, we are assigning user Kate a viewer relation to the folder product. Now, we are using the model's schema where we have defined a viewer relation. We are directly assigning Kate to the product folder. In the next step, we are assigning the folder product as a parent of document roadmap. And you can assume by this point that now, since Kate has a viewer relationship with the folder, and the folder has a parent relationship with the document, by default, Kate should also get access to the document as well. And in the third example, we are assigning user John directly to the document roadmap as a viewer. We haven't given John the full access to the folder. We have just given him access to that specific document. Once we have defined our data, the next step is writing some assertions to check whether the data, whether they have access or not. This is kind of the API call that you make before calling your resource API. This is the check you do to figure out the access decisions. So for the first example, we are checking, does user David have viewer relationship with the document roadmap? We haven't associated user David anywhere in our relationship tuple, so user David doesn't have any relationship, and the response is false, as expected. In the next example, we are checking, does user John have viewer relationship with the document roadmap? Yes, we have directly assigned user John as a viewer, so it returns true. Lastly, we are checking, does user Kate have viewer relationship with the document? Now, nowhere we have assigned Kate directly to the document, but using our tuples and the graph, it is able to inherit the access decision as true. So this is how FGA works. All right, that was enough of talking. Now I would like to demo AI assistant. But before I go into the demo, let me just show you an architecture of how it will work. Remember this example from before? So I have tried to build something like that using OpenFGA. OK, so when we implement FGA in our RAG pipeline, there are mainly two approaches to it. The first approach is called post-filtering. In this approach, what we do is, when the user gives a prompt, like, let's say, for example, what are the financial projections to your chat assistant, then at that time, we retrieve all the documents which are chunked and embedded in the vector database. And once we have retrieved all the documents, at this point, we have not done any filtering right now. We will retrieve all the documents. Then we apply an OpenFGA filter, where we only select those documents which the user who asked the question has access to. If this question was asked by, let's say, the finance auditor or something, then he might have access to all the finance-related documents, and then he will get a response. But let's say this question was asked by an intern, so at the third stage, we can filter out which documents the intern has access to, and based on that, we can finally create the response back to the agent, and the agent only sees what this user is allowed to access. So this is the post-filtering approach. A better way and more efficient way of doing this filtering is called pre-filtering, where the user asks the same question, but rather than first retrieving all the documents from the embedded vector store, what we do is we first filter out the access of the documents. Now, this works better because in the previous step, the agent had access to all the documents first, and then we did the filtering. Here, we are doing the filtering, only retrieving, let's say, the financial-related documents. We are not retrieving any other document. And then finally, we are generating an answer for that AI agent to give it back to the user. OK, this is the approach that I will be using in my demo. And just a quick architecture of how it will look like. The user will start with the question. This query will be done through a chat, and then we will use OpenFGA SDK to enforce these authorization rules, and we will filter out the documents. And then finally, I'm using a Chroma DB as the vector database for chunking and embedding all my documents, and I will retrieve it using the OpenAI SDK, and finally return the query response back to the user. Okay, and for FGA, I'm using OpenFGA Playground. This is a website where you can practice building your FGA models. This is built by Okta as well, but no sign up is required. You can just go to the website and explore the existing sample models, or they have like samples of how GitHub does FGA, or Google does it, or there are some other niche use cases like expense management and everything. You can use it as a learning tool, because whichever authentication model you create on this website, they are only stored in your local browser. Don't use this in production. Today I will be using it because I'm just making a demo. And yeah, for my demo, this is how the authorization model looks like. It is very similar to the previous example I showed you. There is a user, there is a team. The project can be thought of as a folder, and then there is a document. I just added some more relationships to it, like now the project has an admin, editor, viewer, and then a team hashtag member is a syntax where everyone who belongs to a specific team will have access to that project. And document has like the same. There is an admin, there is an editor, and then there are some inherited relationships like admin from parent project. And there is also a public user star, which is like a wildcard. Like if some documents can be made public, we can use that relationship. And this is how the graph, on the right side, you can see the graph that will be generated from our authentication model, authorization model, sorry. Okay, let me spin up the demo now. Okay, is the screen visible? Should I just visible to everyone, right? Yeah, cool. Okay, this is just an example of a internal knowledge-based chatbot where someone from the company can come and ask questions about the company, and it has like for my demo, I have 4 different user personas. The first is Sandra, who is the CEO. She has access to everything, like any CEO would do. There are like 6 documents that I have created. Some are API documentation. There is like internal SDK documentation. These are all like AI-generated documents. There is some finance-related documents. So the CEO has access to all these documents. Then there is a lead developer. He only has access to 4 documents. And then there is a junior developer. She has access to 2 documents. Then there is a sales guy who only has access to the public API documentation. So these are the user personas. Now when they come to this internal company chatbot, they will ask some question like, let's say we will ask a question. We will select the CEO and ask the question, give me a full summary of project Odyssey, and including the status, technology, and financial performance. And she should get a response from the chatbot, which includes everything. Like it is also including some finance-related data here. But let's say there is a salesperson who comes to the internal chatbot and asks the same question. Since he doesn't have access to the finance document, the AI chatbot can reply back that, hey, as for financial performance, I don't have access to that data based on my permission level. So these are the benefits of using FGA. Like you can limit the response, and you can take care of the sensitive data information disclosure issue. Now, if I can show you all those personas at one time, this is a comparison view that I have built. Let's say I want to learn about the UI UX guidelines for the internal project. Only the CEO and the lead developer have access to it. So they will get a response like this, but the junior developer will get like, I don't have access to the UI guidelines, and the sales guy is getting a response based on the public API endpoints. Now, if we ask a more specific question, like what is the color palette, the CEO and the lead developer get it, that the color palette is blue, green, gray, but the junior developer and the sales guy don't have access to that information. And let's say we ask about the API endpoints. the lead developer has access to some internal endpoints, so he gets more data than the other people. And lastly, about financial projections. So this is where only the CEO has access. So she gets the financial projections, but everyone else gets like the, I don't have access to that data. But let's say you didn't implement any sort of filtering in your application. You were just building a normal chatbot which has access to all of your internal data. Then in that case, we can just disable the FGA and ask the same question again. This is how it will look like. Any random user can ask about any confidential data that your company has, and it can lead to severe data leak issues and policy violations, and it can cause a lot of problem for you. So this is where the power of FGA comes in. And I have another quick demo where I am showing a different use case. This is more of a agentic tool calling use case where there is an expense approval system where I have 4 personas again. There is a software engineer, there is an engineering manager, there is like a VP, and then there is a finance analyst. So let's say the software engineer creates an expense. I will just say food, $200. And now it goes to her expense list. And let's say her manager is Raj, who has the power to approve or reject that response. Now, there is a nice AI chatbot which can give Raj the overview of what expenses need his approval. And here, I also have an example of tool calling. Like, I can directly ask him to approve one of these expenses. Like, this is the expense I just created, expense 104. I can just say approve 104. The AI assistant will automatically decide that I have approval or consent from Raj to approve this expense, and then it will call the API, make sure that expense is approved. But what FGA helps us do is that, let's say I try to trick the AI into approving my own expense. Like Raj has raised an expense here, like expense 201, which his manager needs to approve. He cannot approve it himself. So you can just say approve 201 from Raj's context, and it will say that I tried to approve expense, but it seems like I may not have permission. So this is where you can use FGA to use permissions correctly, appropriately, and only make sure that the people who are authorized to approve expenses do that. So this is another sample use case that you can build upon. All right, let me get back to my slides. Okay. Yeah.
In your first example, how did the AI, how did it know that it didn't have access to the document?
How did it know it didn't have access?
Because it kept saying, I don't have access to that information. How
Yeah.
did it know the information even existed?
Yeah, so it's in the prompts as well. Like I have said that if you can't find anything relevant there, just don't hallucinate, don't give any information by yourself. Say you don't, because that's what RAG is about. Like sometimes it will hallucinate and give you an answer by itself. Any other question by anyone? Okay. Okay, now that you have seen the demo, let me just talk about some tools and resources that you can leverage to build OpenFGA into your solutions. So one of the great things about OpenFGA is the excellent tooling and developer experience that we have. There are SDKs in almost every language, JS, Python, Go, and there is a nice VS Code extension that helps you validate the authorization models as you are building it. There is also a CLI that you can leverage to write models, do checks, everything from the terminal itself. And you can also add it to your CI/CD pipeline using the GitHub action that we have. And these are the APIs. So whatever I showed you in the demo, all those API calls, this is what it looks like. And there are all the functionalities exposed through API for updating the authorization model, writing and deleting relationship tuples. So whenever I was creating a expense in that application, it was automatically creating a tuple in the OpenFGA. And there are also advanced use cases like where you are listing all the relations, like show me all the expenses that need my approval. At that time, you will do something like list objects API. So the API documentation is quite vast and good, and it makes it easy for you to integrate OpenFGA into your application, regardless of whatever language or framework that you are using. And yeah, so to recap, what we have seen today is that the rise of AI agents do bring like some critical security risks, and it mainly boils down to these three elements. The most immediate danger is unauthorized data access. Like if you don't have FGA or like proper permissions or proper authorization, anyone can come in and ask questions which are like quite sensitive to your company. And there is your chatbot is a RAG chatbot. It doesn't know by default that what it should see and what it shouldn't within the document or the knowledge base that you have provided. And accidentally, it might end up exposing sensitive data. And this is the core reason why it happens is because of the second one, which is over provision permissions. Sometimes we end up giving it more permissions that it's needed. And this was the central theme of today's talk. We give it like the keys of the kingdom by default, and it ends up being a massive security hole for us. And keeping these two things in mind, the last one, the business impact of it. So it creates like over-provision permissions and authorized data access create a massive compliance and audit gap, and it makes it really hard to justify where did the leak come from if you don't have like a centralized authorization, centralized logging mechanism, and you need to prove that AI is really secure is very tough. And these are not like trivial problems, but the challenges that come along with it need to be addressed today. And these are the exact challenges that a modern authorization system like FGA, which depends on relationship-based access and control, solves it. And it was built for this. And how does FGA helps us? FGA helps us by making our applications secure, scalable, and developer-focused. It makes it secure because it utilizes the principle of least privilege by giving only the necessary permissions that is needed to the AI agent to perform a task. It is scalable because, as we have seen, it's built on top of Google Zanzibar, and Zanzibar powers like Google Docs, Google Drives, like billions, if not trillions, of access control checks every moment. So it's built for scalability, and it's developer focused because FGA allows you to decouple your authorization from your application layer. So your developers now don't need to spend time writing and managing complex authorization system. Rather, they can spend time building the core features of your application and building more useful GenAI apps. And yeah, there is always the developer experience part where we have a bunch of SDKs and tool extensions and CLI available to make it easy for people who are writing the code. And yeah, some more resources to help you get started if anyone wants to take a picture. The best place to start is the FGA website and the GitHub repo. And if you want to follow for updates, there is the Twitter or X handle for OpenFGA. And they host like monthly office hours where the creators of or people who are actively contributing come, share updates, share projects. It's a good place to ask questions. It's a very active community. And you can always go to Auth0 community as well and ask FGA-related questions. And this is the documentation link. The last link is the FGA playground, which kind of looks like this. This is where you can create your authorization model and the tuples, and then there is a graph that will be created, and then you can also try out writing some queries, like let me just show you one. And I just asked, is department related to user Raj as manage? And it will show you a whole graph of how it led to that decision. So FGA Playground is a good place to try out your tuples and relationships. And with that, I think, and yeah, that brings me to the end of my presentation. I hope this presentation gave you a better understanding of the importance of fine-grained authorization in securing the GenAI apps that you are already building or you are going to build. And I definitely encourage you to explore OpenFGA. It's a new way of implementing authorization, and the community is super active and ready to help out if you get stuck. And yeah, if you, that's my X or Twitter handle. If anyone wants to connect and talk about security, conversational AI, or just travel, feel free to reach out there. thank you so much for attending this talk. I know I'm between you and lunch, so yeah, that's all, I promise. Yeah, thank you for your time and attention today. Yeah. Thank you.